This is the Atlantic Shellfish Group. I'm Abdullah, and my colleagues Christos, Mehdi, and Harrison are pictured from right to left. So for our project, we developed a groundwater remediation system using pump and treat. First and foremost, we'd like to say thank you to our sponsor, Comprehensive Environmental Inc., for sponsoring us for this project, as well as our advisor, Ambrosios Bagzoglou, for all of his time and support throughout this project. So a little bit of an outline. First, we're going to go over the site background and contamination, followed by our approach to developing a chlorinated solvent plume that will later help us design our pump and treat system. After that, we'll talk about our two-dimensional modeling approach and our final modeling results, as well as our pump and treat design. So a bit of a background, our site is located in North Kingstown, Rhode Island, and it was a formerly used defense site for the United States military. It was later found that there was contamination on the site, and contaminants included VOCs, PHs, PCBs, and other petroleum products.
So this slide illustrates the hydrologic cross-section of the stratigraphy of our site. So you have a 10-foot thick clay confining layer between the two soil layers with some silty clay lens in the upper layer. So one of the main design considerations we had before modeling was to decide whether we wanted to focus our modeling on the confined or unconfined layer of the aquifer. And we decided to go with the unconfined layer due to having more given lab data and sampling results of the unconfined layer. So we decided to illustrate that. So knowing that we had to focus on the unconfined layer of our aquifer, we were then able to use field data from shallow and medium depth wells to create a plume rendering using ArcGIS that displayed various hotspots of where highest concentrations of chlorinated solvents could be found. So for the scope of this project, we decided to average the 4 highest chlorinated solvents found, PCE, TCE, DCE, and vinyl chloride, and the plume had an average concentration value of 1.64 micrograms per liter.
So now I'm going to be talking about our model, which we use MATLAB as the base language. So before we could run the model, we needed two things, and that would be the plume rendering that you saw in the previous slide using ArcGIS, and we also use the same software to run the hydraulic connectivity. Therefore, we have those two rasters, and then we can import those into our model. Next, we had to decide the locations of the extraction and the injection wells. This was done through trial and error optimization. So the initial locations were chosen, and then through iterations, we decided on the final locations. Next were the boundary conditions, which those were made through assumptions, which are justified in our report. So here are the results from our final model. And as you can see, 100% of the particles were removed from the modeled area. This means that the pump and treat system that we designed was able to remediate the entirety of the southern plume. And this was done in a total of 709 days. So without the reinjection wells in the north, that was actually around 800 days. So this spread it up by about 91 days, therefore justifying reinjection in the north.
So now to talk a little bit about our pump and treat design and the specifications that go along with it. So we have Schedule 80 PVC piping with a total length of 1,137 feet, and that will connect our 6 extraction wells to our air stripping tower, which will then perform our remediation of the groundwater, and then we will send the remediated groundwater to the northern portion of the site with 3 injection wells, and those will put the treated groundwater back into the ground, and it will act as a barrier to prevent any contamination coming from the northern plume of the site and trickling down back to the southern part of the site. We're using a pump that's 140 gallons per minute and an air stripping tower with a height of 21 feet. Now our final cost analysis with capital costs, O&M, and design fee yields a total cost of $2,447,807. Thank you. Any questions?